and there is a table under me. They were starting the gauge on the part, it got stuck, so what they did, they held the part and they got a monkey wrench and were cranking the gauge down. Hey team, I'm trying out a different audio so you don't hear all the crazy, obnoxious, insane background noise and you are stuck with my obnoxious voice instead. Let me know if it sounds a little bit better than previous videos in the past. So as you can see today, I am wearing my Sunday best shirt. That means that we are getting down to business, covering a very serious topic. Is it controversial? No. Is it something that a lot of people don't know? Not at all. Is it something new that no one's covered? Absolutely not. But it is super critical in our field of CNC machining. If you're a machinist and you're making chips and you're breaking the chip and you got great surface finish, your status light is always green, your efficiency is through the roof, that's awesome. But, this is a big, big but. If your parts are bad and they're not conforming to quality standards, what does it matter if you're breaking a chip well, if you get a good surface finish, if your tool life is through the roof, if you're saving money here, doing this, doing that. Part quality is super critical in what we do. So today what we're going to go over in this video, you're going to follow along with me on how I check a part, not completely all the way through, but how I do some in-process inspection on some basic and also not so basic quality measuring tools. We're going to grab a part right off this machine, go over checking it, how I would do some basic in-process inspection. Now, I know what you're thinking. What's in-process inspection? Well, you have your part approval, like your FAI, first article inspection. That's when you run through the entire part to make sure 100% of the features are good. Then, if you do outgoing inspection, you would also do outgoing inspection, take a certain sample of parts, check certain measurements on those parts, make sure that they're good. But in the process of your first article inspection to your outgoing inspection, the machine is running, making parts. We call that our in-process inspection. After the machine is set up and running, the person who's running the machine has to make sure it's good while it's running. That's what we're going to go over today. We're going to hit it. You're going to follow me and see how I do it. Let's get right to it. All right, machine is running. Grab our air gun here. Locate a part. Careful, this might get a little loud with the air. Make sure that we're cleaning off any coolant, chips, debris, anything like that. Mandatory drink of coffee. Now the first thing that we want to do is, I'm not going to go over and show the print for obvious reasons, but we have an OD thread, outside diameter thread, a little shoulder, diameter here, a bunch of bores on the inside and ID grooves. So we have these sun and bore gauges. We're going to check that, not constantly, but very often. You can see that bore is running a little bit on the low. Maybe it's hard to see, but here's our thread ring gauges. Okay, this is a go and a no-go. The go is green, the no-go is red with this line on the outside. To check our pitch diameter, we want to ensure that that thread's all the way down to the shoulder. You can see that to the shoulder, which it does. And we want to make sure that our no-go does not go on. Hence the term no-go. It stops and it's about less than a quarter turn. I would definitely pass that. Come here on our digital 2-inch quick mic, 1.355. Have to look at our records to see exactly what that's supposed to be. 1.347 to 1.377. Oh, wrong part. Actually, I don't think that's what that was. Hex to hex distance. So that's the size of our hex. Oh yeah, OD here. 1.352 to 1.375. 1.355, a little on the low, but it's fine. Now here's our sterret gauges. These check snap ring grooves on the inside. So we have our minimum 1.252 to 1.259. And we're not going to dive in that far and say, are you sure you're checking the right groove? This is a basic preliminary video to go over some very basic information. Right now you can see that indicator in the middle. We're groovy, pun intended. Next one, we got 3 ID grooves here. So this one's a big tolerance. You can see all the way there is our tolerance. Wonderful. This one will be the one way down at the bottom. Same thing. Pretty wide tolerance. So these sterret ID gauges, they're awesome to use. They're quick, they're adjustable, I think from about 400 thousandths up to, I don't know, 2 inches or something like that. But I want to talk about these ring gauges real quick. My brother told me a story about these ring gauges, and he put it really well. When you're checking these, you don't want to check them hanging out of a 2-story window. Same thing, if I'm checking them, I don't want to be over the table in case it drops, or over the ground. I want to keep it over the table. In case it drops there. These gauges, if you drop, can be knocked out of tolerance. You don't want to drop them, and if you do, let someone know. And then we have here an assortment of pin gauges. I don't know plug gauges, go and no-go. Go and no-go. I don't know exactly what all of them check, but essentially it's a functional check. A go and a no-go to make sure that the bore is good. It's a quick and easy check. Go, no-go. This goes, that does not go. Wonderful for checking bores. Now, what I would not use that for really tight, close tolerances. Although you can, it's just more of a functional check. Now we're going to go over here to something that's not so basic. This is an air bore gauge. So we have our standard here. This here is our calibrated standard. And this is the plug that goes in. You can see there, looking in the red, I intentionally moved it out. So it goes back to the green. We know that bore is good. We're going to do the same thing here. Green. Red. I'm moving it so I know it's not good. Now it's green. So that bore we know is good. And these air gauges are good for dimensions that are super tight tolerance. In this particular case, it's, I think, plus or minus 0.3, 0.0003. We also have a blade mic here. I don't know if this is used on this part, but it's a thinner mic to check groove diameters. So we have our digital mic, our sterrets, our sun and bore gauges, our thread gauges, and an assortment of gauges here. This is just what we use for in-process inspection at the machine. So there we have it, team. That's a very brief, down and dirty display of how we do in-process inspection. We check the frequency on those is based upon the complexity of the part. Like the air gauge I showed you, that's like plus or minus 0.3. We nearly 100% that feature. Stuff like the thread ring gauge, we may check once every 15 minutes, something like that, once every 20 minutes. And maybe that's too frequent, but I would rather check it too much to ensure quality than to check it not enough and have bad parts possibly pass through. Now, I did listen to some of the audio on the other clip. It doesn't sound the greatest, but I am working on it. So bear with me, I will improve it greatly. One story I wanted to bring up with a thread gauge here. I talked to my brother about it this morning. He's a very wise, intelligent individual. But he brought up the story that blew my mind. Somebody at a shop that he worked at was using a thread gauge like this. The parts that they made were a little bit oversized. So they were starting the gauge on the part, and there is a table under me. They were starting the gauge on the part, it got stuck. So what they did, they held the part and they got a monkey wrench and were cranking the gauge down with a big pipe wrench, essentially using the gauge as a die. Now, would I say that's a horrible thing to do? Yes. Would I say that I was appalled and laughed hysterically when I heard it because it was unbelievable? Yes. But I do believe it happened. That's an example of what not to do with a thread ring gauge. In the world of CNC machining, in fact, any machining in general, and I've said this before, quality is the name of the game. We're not plumbers and electricians. We're precision machinists, okay? Not to throw shade at anyone else, but precision is our middle name. If you can't make the parts good, you got to go back to the beginning and determine why. Why isn't the part good? Let's fix that and make it. Quality is the name of the game, and the instruments and the tools that we use are made to uphold those quality standards. Treat them well. If you accidentally drop a gauge, tell someone. Don't use it as a die. Don't chuck it across the room using it as a boomerang or whatever the kids play with. Treat them well. Anyhow, that's the video for today. What do you think about quality? What type of quality standards and tolerances do you hold? Have you used any of the stuff that I went over today in this video? Drop a comment below. It'll really help. You can find me on TikTok, Twitter, and Instagram. Luke at Crusader Machining, Give me a follow, share the video. I really appreciate it. Thank you again for watching, and we'll see you next time.